Welcome back to the Deep Dive. So today, we're talking about distance. But, forget measuring in feet. We're going deep on how to push a digital fire hose. I'm talking 32.4 gigabits per second of uncompressed, ultra-high-res video across distances that are just, well, they're staggering.
Exactly. This is not your standard setup. When you're dealing with HBR3 data rates for a pure 8K signal, 7680 by 4320, and you mandate zero compression, which is a must-have in a lot of high-stakes environments like broadcasting or command and control, you just run out of road with copper cables.
You really do.
And that's where a piece of hardware like the DVIGear DVI-7380 DisplayPort 1.4 extender comes in. It's built for exactly this problem.
Okay, so let's put some numbers on this, the scale. We know standard cables can maybe do a few hundred feet if you're lucky.
Yeah.
When you're talking about going miles, what's the key difference? What lets this tech make that huge leap?
Well, the fiber type is everything. It really is. So with your standard OM3 multimode fiber, which is pretty common, you can get an impressive distance. We're talking over 1,000 feet, maybe 300 meters.
Which is already great.
It is. But the real game changer, the reason we're even talking about this, is what happens when you switch to single mode fiber. With single mode, the distance just explodes. You're pushing past 5.0 miles. That's over 8,000 meters.
Wow.
Yeah. And at that point, copper or even those high-end Cat-X solutions, they're not even in the conversation.
That's amazing performance.
Yeah.
But it brings up a practical question for me. If you've gone to all the trouble and expense of running a 5-mile strand of fiber, you want it to carry more than just the video, right?
Oh, absolutely. And that's maybe the most elegant part of the solution. They squeeze so much onto one tiny strand of light all through a single LC connector.
So what else is on there?
So you've got your main 8K DisplayPort video, of course, and the embedded audio. But on top of that, you get bidirectional IR, RS-232 for control, and, get this, 2 10100 Ethernet ports as well.
2 Ethernet ports?
2 fully functional Ethernet ports, and it's all compliant with HDCP 1.4 and 2.2, so all your content protection is handled.
Okay, hold on. How do you cram all of that video, network data, control signals onto one single fiber without them just crashing into each other? That sounds like it shouldn't be possible.
Right, and this is where we get into the really cool part, the technical nuance. The secret sauce is a technology called CWDM.
CWDM.
Yeah, it stands for Coarse Wavelength Division Multiplexing. The best way to think about it is that the fiber optic cable isn't one single road. It's more like a superhighway with multiple color-coded lanes of light. Each color is a specific optical wavelength, and it carries its own signal.
So we're really doing a deep dive into light itself. How many lanes are on this superhighway?
This system uses 6 distinct wavelengths. 4 of them, 1270, 1290, 1310, and 1330 nanometers, do the heavy lifting. That's for your high bandwidth DisplayPort video lanes.
I see. And the other two?
The other two, 1490 and 1550 nanometers, handle all the auxiliary signals. Your network traffic, the IR, RS-232, the AUX channel, all of that. They all travel together over that 5-mile distance, perfectly separated by their own color.
And if we tie this back to the real-world benefit for an installer, the crucial thing isn't just the distance, it's the integrity, it's the quality.
Yeah.
Because it's light, it's totally immune to environmental noise, right? RFI, EMI.
Exactly. Completely immune. You could run that cable right next to a high-voltage power line for 5 miles, and your picture quality would be pristine. It eliminates all those variables you fight with copper. So the DVI-7380, it just delivers that reliable, uncompressed signal every time. It's also TAA compliant, which is important for government jobs, and it comes with a 3-year warranty. It's built to be a cost-effective, bulletproof solution.
So for you, the person listening to this, think about what this means. We've seen how fiber can push 8K flawlessly over, frankly, unbelievable distances. But build on that idea of immunity from interference. Over 5 miles. Where is that level of data security and signal quality not just a nice-to-have, but an absolute mission-critical requirement?
Yeah, you're not just talking about big video walls.
Exactly. Think about secure, centralized mission control centers, or critical broadcast infrastructure feeding a live event, or maybe high-resolution medical imaging facilities where any kind of signal dropout or interference is simply not an option. That's the real value of pushing light for 5 miles.